In our previous lesson, we explored the decimal number system, also known as base 10. We learned that the value of each digit depends on its position within a number. Today, we're taking the next step by learning the binary number system, which is the language used by every computer. Unlike humans, who count using base 10, computers process information using base 2. That means computers work with only two digits, 0 and 1. At first, binary may seem very different, but the good news is that it follows exactly the same place value concept that you already know from decimal. The only difference is that binary uses powers of 2 instead of powers of 10. By the end of this lesson, you'll understand how computers represent numbers using only zeros and ones, and you'll be ready to read and write simple binary numbers with confidence. Now that we know computers use binary, let's understand what base 2 actually means. In the decimal number system, we have 10 digits, from 0 to 9. Once we reach 9, there are no more digits available. So we move to the next place value and write 10. Binary follows exactly the same idea, but it has only two digits. Those digits are 0 and 1. After 1, there are no more binary digits available. Instead of creating another single digit, we move to the next place value. That is why the next binary number is 10. The sequence continues as 11, then 100, and so on. As you can see in this diagram, the limited number of digits forces the number system to shift into a new place value much sooner than decimal. This is why binary numbers become longer than decimal numbers, even when they represent the same value. The important thing to remember is that binary is not difficult. It follows the same place value concept as decimal. The only difference is that decimal uses base 10, while binary uses base 2. Now let's learn how to read a binary number and convert it into decimal. We'll begin with the binary number 1011. First, write the binary place values underneath the digits. From right to left, the place values are 1, 2, 4, and 8. Next, look at each binary digit. If the digit is 1, include its place value. If the digit is 0, ignore that place value. In this example, we add 8 plus 2 plus 1. That gives us a total of 11. So the binary number 1011 is equal to 11 in decimal. Let's try another example. This time, the binary number is 11001. Its place values are 16, 8, 4, 2, and 1. Again, we only add the place values where the digit is 1. So we calculate 16 plus 8 plus 1. The answer is 25. One important thing to remember is that binary positions are counted from right to left. The rightmost digit is position 0, followed by positions 1, 2, 3, and so on. These positions represent the powers of 2, such as 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, and 2 to the power of 3. Whenever you convert a binary number, simply identify the place values and add together only the ones where the binary digit is 1. This simple method works every time. Now let's learn how to write numbers in binary. In this table, you can see the relationship between decimal numbers and their binary equivalents. We begin with 0, which is written as 0 in binary. Decimal 1 is written as 1. After that, we have used all the available binary digits. Since binary has only 0 and 1, we need to create a new place value. That is why decimal 2 becomes 10. Decimal 3 becomes 11. Next, decimal 4 becomes 100. Then 5 becomes 101. 6 is written as 110, and 7 is 111. When we reach 8, another new place value is needed, so it becomes 1000. Notice the pattern. Whenever all the possible combinations of the current digits have been used, binary simply adds another place value to the left. This is exactly the same idea as decimal. In decimal, after 9 comes 10. In binary, after 111 comes 1000. The key difference is that decimal uses base 10, while binary uses base 2. As you continue practicing, these binary patterns will become familiar, making it much easier to read and write binary numbers with confidence. Now that we understand binary numbers, you might be wondering where binary is actually used. The answer is everywhere in the digital world. Every smartphone, computer, tablet, and smart device processes information using binary. When you open an app, send a message, or browse the internet, your device is constantly using millions of binary digits behind the scenes. Video games also rely on binary to process graphics, player movements, sounds, and game logic in real time. Modern technologies, such as drones and robots, use binary to receive instructions, process sensor data, and make decisions. Even artificial intelligence systems work with binary data. Although AI can understand text, images, speech, and videos, everything is ultimately stored and processed as long sequences of zeros and ones. The internet itself depends on binary. Every web page you visit, every email you send, every photo you upload, and every video you stream is converted into binary before it is transmitted and stored. The important thing to remember is that, while we see words, pictures, music, and videos on our screens, computers understand only binary. That is why binary is considered the fundamental language of all modern digital technology. Before we finish this lesson, let's clear up a few common misconceptions about binary. The first misconception is that binary is a programming language. This is not true. Binary is a number system that computers use to represent and process data. Programming languages such as Python, Java, or C# are written by people and are later translated into binary so that computers can understand them. The second misconception is that computers display everything in binary. In reality, computers process information internally using binary, but they convert it into text, images, videos, sounds, and graphics that are easy for us to understand. Another misconception is that binary numbers are random. They are not random at all. Binary follows a logical place value system based on the powers of 2, just as the decimal system follows the powers of 10. Finally, some people think binary is used only for numbers. In fact, binary represents almost everything inside a computer. It stores numbers, letters, images, audio, videos, computer programs, and every file on a digital device. Let's quickly review what we've learned today. Binary uses only 2 digits, 0 and 1. It is called base 2 because it has only 2 possible digits. Its place values are based on the powers of 2. The value of a binary number depends on the position of each digit. And to read a binary number, we simply add the place values wherever the digit is 1. Understanding binary is one of the most important foundations of computer science, because every modern computer relies on it to store, process, and communicate information.